Hi everyone. So let's talk mesh distribution. I'm going to show you how to scatter objects on a mesh using the various different techniques that exist in mesh. So from scattering randomly to doing edge, vertex, face randomly, using face areas so that you get a more even distribution, voxels, all that kind of thing. We'll cover it all. And then a couple of neat tricks that you can use. So the reason I'm in a scene with the deforming mesh, so this is a skinned mesh, the reason I'm doing this is because this is a tricky thing to attach points to, because as it's deforming, the face areas are changing, and this means that the nicer distribution methods can fall apart because of the changing face sizes. So I will go into this in great detail. But let's just get going. So if I just create a cube and then create a mesh network, what I'm going to do first of all is I'm going to create a surface shader and just give these a kind of bright color so we can see them easily. And I'm going to shrink them down a bit, and then on the way to what I'm going to do is head over to the distribute node, and then I'm going to roll down mesh settings. I'm going to middle mouse drag in the skin onto the input mesh, and what that does is it automatically switches us to distribution type mesh, and the default mode is scatter. So what that means is we're scattering points randomly over the surface of our object. So we can have 300, we can have 3000, we can have 34,000, we can have lots and lots and lots of objects. So let's go back down to a lower number, and I'll just shrink the cube even more so I can start to show you some problems. So at its most basic level, if I just turn off the skinned mesh, its most basic level, scattering is just randomly placing points on the surface. You've got the surface normal here, so you can expand them along that if you want to. And what you'll notice is that where there are more faces, so where the faces are smaller, if I just show you on the original mesh, so small faces on the thumb and the front of the hand there, and big faces, say in the torso. So if I just undo that, solo select and hide the skin again. Notice that so front of the hand and then on the thumb, very, very dense point count, and then in the torso, very light point count. And that's because we're not paying any attention to the face scale when we just scatter these points randomly across the face. So the benefit of not paying any attention to the face scale is that this will deform really well. So there's no need to do anything else. If you want a deforming mesh, this is just going to work fine. However, artistically speaking, having clumped points isn't cool. A couple of options here. One, in yeah, is there? No, I can show you one. I can show you a couple of options later. I was about to turn a button on that doesn't work in this mode, so you'll have to ignore me. Sorry. What we can do is scatter user's face area, and what that means is it will give us a much more kind of even distribution. So you notice how the torso is now as densely populated as the hand, and so we turn that off. You see, remember, clumping and then kind of sparse point counts, and then turn that on. Everything's more even. So pretty cool. Everything remains even when you add more points. It's all very good. Okay, so the bad news here is that when we move everything, notice, look how noisy this foot is. If you just look at the foot on the left hand side here, you'll see that all the points are jumping around, and that's because the face areas are changing, which is, I mean, a tiny change in face area can have a profound effect on the distribution. So if I turn that off and then scrub through, look how stable it is. So we need a way to have this kind of distribution and for this to stay stable and not jump around all the time. You're in luck. I am going to show you how to do that in a few minutes, so you want to skip forward in the video if you've come here to see that. But first, let's go through the other options that we've got. We've got a vertex distribution here, which will scatter on the vertices in order, so starting at 1 and then going up from there. We can also go random vertex, and then for the vertex, face and edge mode, we've also got this flood mesh option, which will just put a point in every one of those components. So that works for face center as well, random face center, and then we've got edge and random edge. Let's go back to face center. Let's go random face center. And if I do flood mesh now, you'll see that yeah, we've got a point in every face. In fact, let's not do flood mesh. Let's do something like this. So same problem as we had with the scatter. The points on where there are large faces, there's fewer points because obviously there's only one point per face, and so when there's larger faces, you logically have larger gaps between the points. And then down here on our thumb, where we had lots of points close together, there are lots and lots of points. So there's a way that you can minimize this in face and edge mode by going into the face edge settings and choosing enable scaling. And what that'll do is, where a face is large, the object will inherit the scaling of that face will be larger because it inherits the scale of the face, the size of the face, and then where the faces are small, like on the thumb here, we get a really small scale. So you can exaggerate the effect of that by using this slider. It might also be handy here to show you that you can offset all of these scales. So if you think, well, I quite like the scale of the large faces, but the small ones have kind of got lost and I want them to have at least some scale, what you can do is just add an offset node to the not to the position channel. You can add an offset node to the scale channel, and then just put a value of, say, something like 0.1 in here. And what that does is it'll add 0.1 to every scale, which means that the minimum scale that you've got in your mesh network is 0.1. So that would be a way to help that, to mitigate that. Okay, so like I said, the smallest scale now is going to be 0.1. So what else can we do? Yeah, let's go back to, well, I'll show you voxel now actually. So in the voxel mode, we have this voxel size. So the larger the voxel size, the fewer points you get, and you lower the voxel size, and you get more and more voxels. So there you go, kind of how that works. You've got this border size which eats into the mesh, so a point will have to be further inside the mesh before it's considered to be inside the mesh, if you will. And then we've got these kind of crazy pattern controls which I actually think are broken in this this release. So hopefully we'll fix that very soon in a hotfix for you. So let's go back to scatter, and this technique that I'm about to show you can be used for voxels as well. If you want to have voxels, if you want to scatter objects to the volume of some things, and you would use voxel distribution, and I'll go through that. I'll go through that later, probably in a video I'll stick onto the end of this one. Anyway, so we've got our scatter. We've got our scattering that's even because of we're using the face area, and we've got all this noise down here, and we don't want it. So what we do is we select our weighter, and what we do then is we go create mesh utilities, create mesh from points. Now what that will do is it creates a mesh with a vertex at every point location. So yeah, everywhere there was a point in mesh, there is a vertex on the mesh that we've just created. It creates a huge mess basically in the viewport, but it's really useful for then distributing onto. So why would we want to distribute onto this mess? Well, because we can skin it, and that means that it will deform properly. So let's do that. What we need to do is select the bones, select this mesh, and then we're going to bind the skin. So the mesh is now going to be skinned and deforming, right? So that's pretty cool, right? Then we need to copy the skin weights from the original dance skin onto the mesh from points mesh, and that's because mesh from points mesh, and that's because you may have painted some skin weights, blah blah. If you're, I'm going to assume you know why you probably want to copy the skin weights, just because you want the animation to be the same. You don't want points sticking through the surface and all that kind of stuff. So anyway, copy skin weights. And now what this means is if I can hide the original root pro mesh because we don't need that anymore. So our crazy mesh is now animating exactly the same as our original dancer mesh. So if I create a cube, well, I could actually just use the same cube as before. I'm just going to create a mesh network, which is over here again. Then what I'm going to do is I'm going to drag this mesh from points onto the input mesh here. I'm going to choose vertex distribution. No, whoops. Vertex distribution and flood mesh. And then I'm going to turn off the crazy mesh. I'm going to shrink down our cubes, and I'm going to assign a shader to them. and I probably want to turn off. They get given these crazy normals, the mesh from points mesh. Mesh from points meshing. I have to stop saying that. Mesh from points. When we make that, we don't do anything clever with normals, and so I think we just want to turn off rotation so that everything's just flat. And now, when we have this really nice even animation, like even distribution, sorry, and when we animate, you see that there's no jumping around. Everything's kind of still and good and happy, and we can get on with our lives. So that is how you do that. Right, so the same thing works for voxels, and what that means is if I turn on my original repro mesh here, and so this is the one that's jumping around everywhere. So if I turn this into a voxel distribution, like so, and let's say I want to have these points randomized slightly. What I'm going to do is I'm going to eat into the object by, say, 0.5. No, I won't do it like that. What I'm going to do is well, there are two ways to do this. Actually, I'll show you them both. So yes, what should I do? Okay. What I'm going to do. Thinking on the fly, it's not my strong point. I will just do the same thing. I'm just going to grab this waiter, and I'm going to do the whole mesh from points thing. And then I'll show you something clever you can do. So we've got this, then I'm going to do the same thing. I'm going to skin, and then I'm going to copy the weights over. And then I'm going to, on the second mesh network, which I hid, so I'll hide the first one, show the second one. On the second mesh network, I'm going to swap the meshes. So I'm going to put this mesh from points 2, and I'm going to copy it over mesh from points 1, and then I can hide that, and we've got our second mesh network. So these are now voxels that are kind of deforming properly, you're in the right place, all that kind of thing. So that's cool. But let's say we want to shake this up a bit. We want to randomize these positions slightly. What we can do is, on the second waiter, we can add a random node, and that's way too random, although still pretty cool. So let's just say we want to make these look like we've randomly put them inside the volume. The trouble is, a few of them have gone outside the volume, and that might not be what you wanted. So what we can do is we'll add. Now there are two ways to go about this. The reason I was umming and ahhing before is because we can use the border size on the voxel distribution to kind of push everything into the mesh. And then when you add this random later on, the objects are much less likely to reach the surface of the skin. So I'm probably explaining that really badly. But so you can use border size to mitigate this somewhat. Or what we can do is we can use a fall-off object. So let's do that. So let's add a visibility node. And what a visibility node does is obviously just turn off fall-off objects. Pardon me. So I'm going to create a fall-off object, and that means that only the... What did I just do? Oh my god, what, my scaling is set something crazy. I don't think I'm going to use the scale manipulator. So I think I'm just going to up these numbers here. And where's my dancer? There is my dancer. So, oops. Okay, there it is. You see, right, we can use a fall-off object to control what points are visible and what points are not visible. And if you remember from, well, if you've watched my other video on the fall-off object, you'll know that you can not just have a sphere as a fall-off shape, you can also have curves and particles and cubes and also meshes. So let's do that. On the fall-off object here, we'll roll down connections and we can drag in the original skin. So if as soon as we do that, we get switched to this mesh shape mode, and then in the additional settings, all we need to do is change the custom shape radius to nothing. And with that done, the points that are outside the mesh should get turned off. So we're if I I can show you this working if I increase this random. So if I increase this random lots and lots and lots, you see as the points go outside the skin, they get turned off. So, and that's because we're using the skin as the fall off shape itself. So as we reduce this random, then they're kind of like becoming visible again because they're inside the skin. So that is how I would create a random volume distribution with mesh. Now, it's slightly convoluted, but it works perfectly for deformation. So yeah, it's just that's the technique to use, and hopefully someone will find it useful. Okay, thanks for watching. Apologies everyone, it turns out I was not done. I quickly just want to go back and cover a couple of bits I forgot, and they are edge scaling and then component selection sets. So yes, what have we got going on here? Bear with me, I've just broken everything. Okay, right, let's go. So I have, I'm back on the original distribution that we had, so I can, change it from scatter, vertex, random vertex, all that kind of thing. So let's change this to edge, random edge, and then in the face edge settings, we've got this enable scaling on, but as you can see, it's not really doing anything. You would assume that this would stretch these cubes that I've got in the mesh network to kind of like be the length of the face, and the reason it's not doing that is because I messed with my cube scale. So the cube scale was it needs to be 1 for this to work basically. So if I do that, then our cubes are now the length of our edges. However, it's height reliant. So what I can do is I can make them thinner. So if I go 0.2 in the width and 0.2 in the depth, you'll see that our points are now the length of our cubes are now the length of the faces. So short face length down here, long ones here, and then if I turn that off, you've got kind of a cool effect in itself. So yeah, that's one of the things I wanted to show you, just that when you're using scaling with an edge, you need to make sure that it is scaled to 1 in XYZ, and then having a height of 1 in its original cube setting. So that's how that works. The other thing I wanted to show you is that you can use vertex selection sets. So we've got this option down here called selection set, and if I disconnect the main mesh, because you don't actually need a mesh in this option here, in this box here. If you have a mesh in this box here and you have a vertex selection set, what will happen is that the vertex selection set will update every frame. So if you've got an animating mesh, so if, then that might be useful. Anyway, for all intents and purposes, all you need to do is middle mouse drag a vertex selection set into the selection set box. It will change you to vertex selection set mode, and then yeah, it will add. If I select these verts here, you can see where they all are. No, you can't see where they all are because the mesh is hidden. But lots of verts there. So we've got flood mesh, so you can flood the mesh, so you can have every vertex in your set have a point. Now, something that we added in right at the last minute, and so hasn't made it into the interface, is the fact that you can also use face selection sets and edge selection sets. So there's a face selection set gone in, and that works, cool. So notice that this method here is still called vertex selection set. So we couldn't change the interface at the point that this feature went in. So you can put edges and you can put faces in here. It's just that the mode will say vertex, but they do work. So like I said, there's flood mesh, and yeah, that works. And so those are the two things that I missed that I just wanted to cover. Yeah, so thanks for watching.